All right, so we've got to get used to using the tables. And what if I said that you had water that existed at 400 degrees and the pressure was 1,000 psi-A? Well, do you know if that water is saturated right now? If I added energy to this water, would it go to 401, or is it already saturated? Or is it potentially superheated? Well, let's see how the steam tables help us figure that out. I have 400-degree water that exists at 1,000 pounds. You know what that is? Let's say that's feed water. So I go to 400 degrees in our steam tables, and I see that the saturation pressure for 400 degrees is about 247 psi-A. We have it as 1,000 psi-A. So I'm really subcooled. Let's go verify that. Let's do it another way. Let's go to the other tables and let's go to 1,000 psi-A and see what the saturation temperature is. In the pressure tables, they're not broken up as much as well. You'll see that these are the pressures here, and they're the same numbers. If I was to go look up this temperature for its corresponding pressure, I would get that one. So let's go to 1,000 psi-A, and it's at the bottom of this page on mine. I have 980 and 1,020 right here, 980 and 1,020. Halfway between 980 and 1,020 is 1,000 pounds. So halfway between 542 and 547 will be the saturation temperature. So the saturation temperature should be about 544 degrees. So T-sat at 1,000 pounds equals 544 degrees Fahrenheit. This water exists at 400 degrees. So it's subcooled, right? Temperature subcooled equals T-sat minus T actual. Well, the saturation temperature is 544 degrees Fahrenheit minus 400 degrees Fahrenheit. This water is subcooled by 144 degrees Fahrenheit. On a TS diagram, it's down here. This point right here represents 544 degrees. That's where it would become a saturated liquid. It would still be 544 degrees over here, but it would now have been turned to 100% steam. So we're subcooled by 144 degrees. So there's lots of applications for the steam tables, and we're going to get some practice here in a minute with some sample problems, but we could look up the enthalpy at this point, the F point of a saturated water. I could look up the enthalpy of a saturated vapor. I could determine if the condition that I presently have my water and the state that is in is subcooled or saturated or superheated. And in this case, we found out that if it was at 400 degrees, our water entering our reactor, operating at 1,000 pounds and 400 degrees, is subcooled. Little look ahead here. Here's a fuel bundle. So water enters subcooled into the reactor. We know that it gets preheated in the downcomer and ends up going through jet pumps. Gets a little warmer and preheated. Enters the bottom of a fuel bundle, subcooled. At some point, boiling starts to occur. This is where saturation occurred in a fuel bundle, and this is nothing but an increase in enthalpy as it travels across the fuel bundle. The 24 heating elements essentially in series, we'll find out. And we'll find out that we exit this fuel bundle about right there on the vaporization line, which is about 13% quality. So somehow, before we ever send this steam to the turbine, I'm going to have to get it from there to there. I'm going to have to remove a bunch of moisture. And we'll figure that out too.